Hey, so today I thought we might do something a little bit fun. People may ask you whether Pascal is still useful, whether or not you can develop something modern in it. And while the answer to that question is obviously a yes, it's not something I'm going to really debate. And instead, what we're going to do is to build a complete snake game in Free Pascal, and we're going to be running it on Linux here. So, and honestly, projects like this can be a nice little distraction. We've released a few videos on the human side of coding, so getting back into something that's programming oriented, can become a nice distraction. A little bit of nostalgia, even a few minutes of gameplay, especially if you grew up like me with on older computers, and this is a memory of your past. So, like I said, it's simple, it's retro, and can be relaxing as well. And Snake can be the perfect game for something like this because it's small, it's visual, it's interactive, and it lets us make something real without getting lost in the complexity. So, if you're developing let's say even just a 3D version of Snake, you get lost in the camera, the shadows, and goodness knows whatever else, the maths of it all, where you lose focus on the fundamentals of of the game. And sometimes that's what we really need, something, a reminder even that coding can be joyful. So, like I said, we're going to be using Free Pascal and ncurses. If you don't have ncurses libraries installed, you can just use a sudo apt install command for that. In the description on GitHub there will be the command that you can just copy for that one. And that's all we really need for this program here. So the basic structure here is basically we're going to have a program. We tell our program that we want to use the ncurses library. A bunch of declarations obviously here. Our border, where our snake is, how big our snake is, what direction our snake's traveling is, where the food is. Ultimately the score becomes how many bits of fruit we've eaten, and then and how fast our snake is moving. Some code that we may look at in a bit later on, but when we jump down to the bottom here, this is the main routine of the game. Let's see if we can get that all in. Where basically what you'll see here is a bunch of initialization, which will basically which we use to color our snake. Tell the thing that we don't want to have any echoes, and we just want to have non-blocking keyboard input. Then basically we'll have our game loop. Now, a game loop is typically with all games, which consists of drawing a screen, getting some input. Drawing the screen, getting some input, acting on that input, then redrawing again. When the game's over, we then tear everything down. And even the game loop itself up at the top here reflects the clarity or the readability of Pascal, where we before just down here we initialize the game, but then we basically will then be drawing the elements onto our terminal screen, getting some input, moving the snake, and then just waiting for the next bit of input. Now, looking at all the code here, you might recognize or see that there is no object-oriented code being used. No classes here. I'm going to go fast to say that modern Pascal isn't really that dogmatic about the use of object-oriented code. If you disagree with me, let me know in the comments, but to me, you use it when it helps, skip it when it doesn't. And maybe for something that's small and simple, like the snake game here, that the procedural code might actually be clearer. It allows us to keep focus on the idea and not the structure, because while we could represent the snake as having a not set of points, a length, etc. we can then get lost in the mechanics of what should be in the class or what shouldn't be. So what we do see here in the game then is that our snake up the top here is really just a collection of points. We do have some direction variables here. This is how big our snake is. And that tells which direction we're going in, and hopefully we are heading in the direction of the food, which also has an XY location. And then how much fruit we've eaten, and then whether or not our game's over. And if our game's not over, what's the delay, which ultimately represents the speed of the snake. These are small ideas where we've got predictable movement based on the direction and updates in terms of the screen display and so on, or the state even, like which direction we're moving in. These show up in just about everywhere in software. And before we talk a bit more about that, sort of like it reminds me of the Karate Kid movie where I can't remember what number film it was in, but Daniel was getting frustrated because Mr. Miyagi had him painting the fence, cleaning the car, wax on, wax off, all that sort of stuff. And then Mr. Miyagi, at the end showed him that these simple movements were actually the foundation. And the snake game can be a little bit like that as well, where the ideas here can be used in other types of software. Whether you are displaying the temperature of the outside or the air conditioner, whether it's a financial application or call accounting, whatever, all of these ideas are used, and sometimes a small program like this can teach these sorts of lessons. So basically, just a quick run through a few of the functions here. The init game function, basically what it does is sets up our variables for our game, and that's like how big our snake is, where our food's going to get positioned, random location, hint, and then basically by default we're going to be moving to the right, we haven't eaten anything, etc. Now drawing the game up, again we've got to draw a border, then we've got to put the snake in the screen, then we've got to put the fruit in. So basically, these that become their own individual functions. So we draw our border, we can then draw our snake. And actually here what I will say is that you could have this line of code here inside the loop, but I pulled it out just for let's call it an optimization, and then we can draw the rest of the snake. The idea is that I'm not saying that the compiler couldn't optimize that for me, but would it? Let's not have that guess, shall we? Drawing our food is another bit of code here, and then we want to put some more food somewhere once we've latched on to the first bit. And here is where, let's say, the game proper almost starts, where what we need to be able to do is to get some input from the user. We're using the get function from the ncurses library, and what that basically is non-blocking input. The other bit you'll also notice here is that we have some rules here in place. So let's suppose now, initially when we start the game, we are heading towards the right hand side of the screen. So if we are heading towards the right hand side of the screen, then our direction X is 1. So what we don't want to be able to do is to do a 180-degree turn, and essentially what would happen is we're going to start eating ourselves. And you know that in the snake game, if you turn or if you start, it's in essence eating yourself, it's going to become game over. And really what we're saying here is by saying, providing we're not going right, we can go in a left-hand direction. The other way of saying this would be if we're going up, down, or left, then we can continue going left. That's the other way you can see that sort of action. And while one could say that one could map our input into an enum type, like we want to go left, up, or down, which would enable you to say something like, if new direction equals or in, up, down, or up, down, or left, then we can go left. Here we're just going to say, well, providing we're not going right, then we can go left. I hope that made sense. Now, as I said to just a bit earlier, then we have the food gets placed in a random location, and the idea is for the snake to find the food to eat it. And that all happens here in this move, snake routine, where what basically happens is, based on our direction, we want to, our head will go into that new position. But then we need to also do some checks. We need to make sure that we don't hit the ball, or we aren't colliding with the border. We want to make sure here that the snake isn't going to start eating itself. And in either of those cases there, what we're going to say then is that, well, if that happens, the game's over, and we will immediately exit from this function here, or procedure I should say. And then, if we do move into the new location, we want to shift everything, across by a bit and put our head into the new location. And our last check in this function then is to, well, we move, have we found the food? And if we do find the food, then basically our snake has to grow, we update our score, and every time and as you know, every time we eat a bit of food, the snake grows a bit larger. Every time the snake has found the food, we need to put some food, and we put that food into a random location. And then the last bit of the game, the last function here then is, what is our current score? Now here basically is where, like I said, all the hard work has been sort of done up here, but the hard work is also here. Because basically what we need to do is throw this into a loop where we can draw the border, draw the snake, draw the food, put in our HUD, and then draw all of that. And then what's going to happen then is to get some new input, and then move the snake and apply our rules to determine whether the game's over, or do we make it go faster, etc. Now here is the best part, where we can, play the game. It builds. Well, actually, let's make sure it builds first, actually. Quick game, compiles quickly. Okay, so here's our snake. You can see it moving. Whoops, hang on. I wasn't paying attention, sorry. Here's our food. Here's our snake. Let's see whether we can eat some food. And you can see how hopeless I am with this. Oh, I hate it when they put it right on the border. And you can see why. I'm not very good at this, am I? I can program better than I can play a game. It's simple. It's retro. It's a nice break from the heavy stuff that you might deal with on a daily basis as a developer, or even feeling or this is good for if you're learning to program. But sometimes a few minutes of fun is what we need. Let's see if I can have another go. Where's my? Oh, they put the food right on the border again. There we go. Got it that time. See, I can play the game if I want to. Anyway, so that's the snake game, and it's in free Pascal, full of useful ideas even, just like, Mr. Miyagi and Daniel with his wax on, wax off, and the fundamentals of or ideas that you'll find up everywhere, regardless almost of the type of software you're developing. And if you'd like to see this in another variation, be it a graphical version, let me know in the comments. If you'd like to see some other small projects like this, let me know, because coding doesn't always have to be serious, and maybe sometimes a little game, retro game such as this can help bring back that spark, why we got into computing. But that's about it for this one. I hope you got something out of it, and until next time, happy coding, and I'll see you on the other side, and bye.